Now that we know how to find asymptotes, we can graph rational functions. So a lot of this isn't new. You've been doing this since the first semester, like finding the domain. Remember, that's when you take the denominator and you solve for any value of x that makes the denominator 0, right? And then you need to simplify because that just makes calculations easier in the long run. Now the new thing is to locate and plot any asymptotes. So you want to do that in the very beginning, and you want to plot them on your graph to help you figure out what's going on with the function. And please don't forget to take note of any holes. Remember, when you simplify, if the domain restriction goes away, it creates a hole in the graph, and so you have to put that little hole in there as an open circle. The next thing you need to do is plot X and Y-intercepts like you do for all graphs. Next, you want to plot at least one point on either side of all of the x-intercepts and the vertical asymptote. So what you think of is you think of that x-axis as a number line, and you plot the x-intercepts and the vertical asymptotes, and they break up the number line into different intervals, and you have to check either side of these x-intercepts and vertical asymptotes to see what's happening with the graph. And then you have to note any even-powered factors, and I'll explain why in a little bit. And finally, note end behavior. Okay, so don't forget that if you have a horizontal or slant asymptote, your graph has to approach it. And if you have neither of those, then your rational function is going to have end behavior like a polynomial, meaning it's either going to increase or decrease. Okay, so now let's talk about why you have to do these 5 and 6, the plotting either sides and then noting any even factored powers. So number 5 helps you see how the graph approaches the root or the asymptote. So you have to look on either side. Is the graph approaching the asymptote from below, or is it going to approach it from above? And the only way to determine that is to figure out some points on either side of the asymptote to see what the graph is doing. Now, one thing that can help you with this process is this whole even powered factor thing. Because if you have an even factor or even powered factor in the numerator, what you get is something called a tangency at the root. So in the case of f of x equals, the quantity x minus 2 squared over x minus 3, this x minus 2 is an even powered factor, which means the root of 2 has a tangency. It goes up to 2 and then crosses back down. And that's only going to happen if this degree is even, much like it does for polynomial functions. And then what it does in the denominator is a little bit different. It has something to do with the asymptotes. So an even factor in the denominator gives you something called togetherness at the asymptote, because remember, the denominator tells you where your asymptotes are, and if this factor is squared, or to the 4th power, or to the 6th power, instead of going in opposite directions, what's going to happen is, as the graph approaches the asymptote from either side, it's going to go in the same direction. In this case, they're both going towards negative infinity, but they could also go both towards positive infinity. And this is what I mean by togetherness at the asymptote. Now, I'm not going to do an example in the lesson, because that's what you're going to do in class next time, is you're going to graph a whole bunch of rational functions.